So
Okay.
we're convening again. Hopefully, we're all in a biologically stable configuration and ready to listen to Jan Erik talk about three geocases.
Thank you. I'm not sure if I'm going to get through the two other slide decks, so I'll start with the maybe the most exciting one, the open source VPS that has been put together by a team of Nokia on a project. So today I'm kind of the substitute teacher. It's actually Dr. Gabor Soros who should have been presenting this. I think he might be on a vacation. So please don't throw paper airplanes at me just because I'm the substitute teacher. But yeah, I want to really give a great big thanks to Gabor and his team at Nokia for this work. Also to NGI Search for funding this project. So I regard this open source VPS battery is included that you can download from the GitHub as a milestone. Okay. So I'm gonna try and be a little quick. We've known for some times that there's this potential with augmented reality to combine information and overlay it on the real world. And you kind of in like Google Street View today, you have something that looks like an AR experience in your web browser, where you have this kind of clicks on bricks, and that is much in line with what we're expecting. But Google is providing a proprietary solution, and we're in open geospatial consortium and metaverse standards forum context now, so we want to do better than what Google is doing. So if you today want to use Niantic or Google or some of the other proprietaries, you're kind of stuck inside their little ecosystem, and there will be high switching costs. It's not like a single protocol and single standards. So yeah, I think this concept here about a map that you build, just like what Augmented City explained, that there's a mapper and there's a way of anchoring when you have localized to that map, and then you can have these shared experiences. This is kind of the fundamental premise of the AR cloud, that these maps are in the cloud, and that that allows to this kind of precise and accurate 6 degrees of freedom pose that you would need to realize this vision. So it's been around for quite some time. I think this was 2017 that Google announced their VPS system, and they're one of the key players. You have Apple and Meta and Niantic, but we also have these cool smaller players that are not playing this locked-in game of high switching costs, but instead they are supporting an open ecosystem, which is the future. A little bit of context for the technical aspects of where global VPS fits in. So there's this kind of complementarity between what happens on the device. The device doesn't allow to store the whole world, but it can track its immediate surroundings and have kind of a good high frequency update of the pose frame to frame, 60 frames a second, using visual inertial odometry or other SLAM methods. But you get drift over time. So the combination of drift over time and the limited resources, if you actually want to anchor to the real world in a consistent way and for multiple users, you need to have this global frame of reference, and to avoid the drift. And you might need the kind of resources you can have on the server, and both the space and the compute. So yeah, so you have this like local SDK plus this global thing. So we're looking into maybe having this standardized VPS protocol become the next important step for this ecosystem. Zoomed out perspective, we do have an inspiration from the open web platform, where you have a set of standards, protocols, and services, and where the clients can use these protocols and standards to communicate with the services. And back in 2019, we had this vision for the open spatial computing platform. And even before OGC had their working group, we saw that there's a need for this GeoPose standard to be across this platform. Currently, the more recent way we explain this, now that we have kind of built many of these components of that platform, it's more like a edge device versus spatial services. Those services are intended to be local. These are not like your huge data center kind of thing where a big corporation controls everything for the whole planet. This is something that can be run locally and also controlled locally. And of course, we have this visual positioning service at the center here. This protocol we outlined quite a long time ago. There has been this iteration, so this is the version 2 of it. There's a URL here where you can find the specification. So basically what you want to get is this response, but to get that, you send a request containing some data. So it could be, the typical case would be imagery and maybe a rough geolocation from your GPS on your device, but we're kind of implementation agnostic. There's no requirement that the GeoPose protocol has to be used for a VPS service, but that's kind of where we are today. So with this protocol, then you have the same protocol for all the endpoints, and there's going to be trivial switching cost. There's going to be no vendor locking, and you have actual healthy competition on price and performance between the different vendors. So the OpenVPS that has been built now is available for self-hosting for academic research, and also provides a scaffolding for protocol compliant commercial VPS. Augmented City has been a huge help for OpenAI Cloud through the years because they were so early in providing a compliant endpoint, and we have used Augmented City for a ton of our early demonstrations. But now we can also use our own open source, less performant maybe, but still a great opportunity to be able to do that. And Immerso, which also kind of were early, but we had this little change, and then they had to like be compliant once more. So they are soon to be expected to have a compliant endpoint up and running again. And Multiset is a new entrant that wants to provide this compliant endpoints. So maybe we'll get that early next year, one can hope. They already actually in their endpoints now provides a response that contains an OGC GeoPose. So it's not the full GeoPose response according to the protocol, but it's OGC GeoPose compliant. So could your company be the next, or maybe your R&D university academic research project? Let me see, how am I on time? I'm kind of, okay. Yeah, so a starting point, if you want to look into, you could look at some of the GitHub repos. I'm going to try and move forward to the more of the meat of the OpenVPS. So I said it's batteries included. We are working on our own kind of recorder app, but for currently now we're using kind of third-party, freely downloadable app that you can capture images with. So it's a little bit like the AC scanner. And then you get this bundle of images that you could send over to the map builder through, there's like a web interface where you can upload your files and it will get processed. Into this point cloud. Now you have like a 3D 3D representations of features that could be used by a localization service to localize to the points, but that wouldn't do the whole trick. We need to align it to the physical worlds geospatially to have a GeoPose. So there's also this other project which is web-based and uses OpenStreetMap so that you get the building footprints. That also allows you then to move your point cloud around until it matches the building footprints. And then you get this alignment transform so that when you set up your GeoPose service, which is another part of this project, maybe the most essential one that implements the GeoPose protocol, you send your request there, and now you've matched to the feature point, and it has this geo alignment, allows you to get a proper GeoPose back to your AR experience. So yeah, it used to be on the Nokia GitHub. Now it's on the OpenAir Clouds GitHub and it's very well documented. So I really encourage people to go to this URL and check it out. So this is how it looks when you have this point cloud, and here's how it looks in the map aligner. And here's the current photo capture app, which is Stray Scanner. But we're also working on this other open source project that will be a more comprehensive way to capture the reality for different VPS systems. The map builder, here's where you upload your data, and then it gets processed, and the point clouds is generated. And yeah, the current technology in the open source VPS relies on hierarchical localization, which is one of the kind of little more updated ways to do pose estimation. So it leverages convolutional neural nets, which was not what you did in the early days. So it's moving in the right direction of using more modern approaches. Yeah, I think maybe I'll drop out of this and I'll see if I can show you quickly from this other. Okay, this is what you're seeing here is this cesium viewer where you can do different things. I'm sure many of you are familiar with cesium. So this is kind of a remake of an earlier demo that OpenAir Clouds did with Michael Vogt. Before there were these 3D tiles. Now we have these Google 3D tiles, so we get a more interesting experience where we could, what you just saw now was a demonstration of using the GeoPose service to localize and then move the cesium camera to that pose. But if I jump out of this, how am I on time? I'm pretty close.
You have 2 minutes.
Yeah. Okay. Let me see. Okay. What
Yes.
you get instead? This was maybe not the right one, but what you have here is are two people at the same time using different devices, localizing, and they have a shared space where they can both place these Minecraft blocks. And so you see Gabor there, our research scientist. He's looking over at, from his phone, you see what he's seeing. And then there's the other view from the other person. So I'm going to move to a couple of more slides. So what you're going to see now is a streaming of poses, which is which allows you to visualize in real time the pose of the other person in the experience. So you will see this little these coordinate arrows around, like there's a little origin, and you have red, green, and blue arrows indicating axis directions for their individual pose reference frames. And here's a globe view demo where you can stream the same poses up onto a desktop viewer that could log in from remotely and look at the poses of people on the ground. So there are,
Jan-Erik, we
yeah,
need to
we're,
conclude.
yeah, sure. Thank you. So
Thank you very much, Jan-Erik.
I'll end it there.
Appreciate it.
My name is Ali Hantal. I am the founder and CEO of XR Masters, the creators of my GeoVerse geospatial AI and XR management platform. Today, I will be talking about a few demos, but all right. Why that's not working? How about now? Oh, right now. Okay. Let me talk about a few examples.
Renowned brand nation.
In the past, we are able to place multi-user persistent and shared content through our MyGeoVerse platform. And you can see that these could be any game that is created in Unity. And if you use our studio to implement that to our platform, then you would be able to, as any individual developer, you will be able to have games and experiences multi-user, geospatially anchored, and around 10 centimeters accuracy. So this was in Taksim Square in 2022. That was in Istanbul. We worked with the municipality there and a few sponsors like Turkish Airlines, and people were able to play this game. There are other examples that we worked on, and I would like to show you this one. This was last year during Techritory in Riga. Riga Technical University students, there are our test bed in OpenAir Cloud. They were able to create that content you just saw there, and I want to show you again here. That was in GITEX, yeah. So anything that you see over here was created by students. They uploaded their content, and this was a purchased 3D model, so we placed that. And then when you go up, you will see that there was this Ukrainian street artist, amazing artist. We were exhibiting her artwork during the convention in Riga, in Latvia, and persistently located content. And of course, you can do a lot more with that, like AR wayfinding that I'll show you. But I went to Kuldiga Museum prior and scanned a few artifacts. And then we were able to upload that as content to our platform. And we were able to exhibit that during the exhibit, which is an hour from Riga. It's Kuldiga, city of Kuldiga. And we did that on other use cases as well in the city. So I would like to show you one other very important example that we are focusing on, and that's an AI tour guide. We believe we need this.
Hi there, I'm your My GeoVerse AI assistant. Tap again to chat with me. How can I help you today?
Hi, I'd like to shop for jewelry. Could you please take me to the nearest store and tell me about it on the way?
Little Switzerland is a well-known luxury jewelry store located at Royal Crown in the US Virgin Islands. I'll take you there now, just follow me, please. They specialize in high-end jewelry and watches from renowned brands. The store offers a wide range of products including
So you can see that AR wayfinding is happening. Actually, to give the truth of this was edited. That AR wayfinding the AI didn't pull it. But think about today's AI. We believe AI needs to be geospatially aware. And that's why we are now working on several projects, actually trying to get one in Forum Labs under MSF, Metaverse Standards Forum, to work on this with the first Forum Lab of which is PNET. Actually, Jan-Erik talked about this slide, And I'm not going to go over that, but this is the protocol flow for the OSCP. And I now would like to talk about that demo that we did in March of this year. This was our demo 102. Actually, it's a second demo. We started from 100. But this demo actually has one publisher and then two clients. One of them is a native mobile client, MyGeoverse, which is the MyGeoverse platform's app. And then there's another app that is Sparkle. That's the WebXR client app of OpenAir Cloud. They both used VPS for Augmented City. And like Jan-Erik said, Augmented City has been supporting us for since the beginning. And we are very thankful to them. And we're looking for partners like Augmented City. Again, thanks, Katharina, for being helpful. So you can see that I am right now placing an OGC logo using my GeoVerse app. And that is using Augmented City for localizing. And then I also placed a point of interest, which is also compliant with OGC standards. You can see that as the fire hydrant next to fire hydrant. Now, I am utilizing on an Android phone with Sparkle WebXR client. And you can see that when I hit localize, looking at the same area which was scanned before, it is localizing and is able to discover and visualize the same logo, kind of 10 centimeters to the right, but it is the same content. And when I turn to my right, it's actually fire hydrant is also there. So we believe these type of demonstrations are the key for the future so that we can have interoperable AR cloud, interoperable web, spatial web. And there are information here from that, but I like this slide because we believe everything has GeoPose, including you. I also would like to talk about the next demo that we're working on right now. As you see, this was 102, and 102 had Augmented City as one VPS service provider. And if you look, 103 will have another VPS service provider as, like Jan-Erik discussed before, it's the OpenAir Cloud Open VPS. Now we do have it running, and we're working on the demo to actually use one VPS with my GeoVerse app, publish content with it, and then utilize another VPS service provider, Augmented City, through Sparkle AR, and then discover the content and show that now it's another level of interoperability in AR Cloud. Of course, like Jan-Erik said, we are having two more VPS service providers are working on this right now, Immersal and Multiset, and we thank to them as well. Thank you for working on the SPAN standards. We are looking forward to you getting fully compliant with the protocol as well, so that we can actually start doing demos on a different level. And we're always looking for more partners. So this was my end of my slides. Thank you very much for listening.
Okay, so we have a couple more presentations here. Thanks, Ali, very much for that presentation, as well as for keeping this odd Windows machine running. Now we have a return of Rob Smith to talk about his Compass use case. Rob, are you there?
I am.
All right.
Hopefully you can hear and see me.
Yes, we're trying to see you here. Well, go ahead and we'll figure out how to insert your head here.
Okay, so the slides you're looking for should be the last or penultimate in this set, I think.
Mm-hmm.
Anyway, I will go ahead and talk about it. So the 3D Campus app was developed in testbed 18, and it demonstrates how orientation can be implemented on a mobile device. That was the brief, and how GeoPose can be integrated with that. So I had the idea of...
Rob, I'm sorry, can you please try sharing again? Because I think it was due to our sharing. Can you share again, please?
We're all set, Rob.
Fantastic. Thank you so much. So I'll start again. The 3D Campus app was developed in testbed 18 and demonstrates how orientation can be implemented on a mobile device. That's what we were looking at for the testbed. But additionally, how GeoPose can be integrated with this. So I had the idea of putting together something like a ship's compass. A mobile phone, a smartphone, has all the kit we need for capturing GeoPose. This was originally implemented as a web page for a mobile web browser and then ported to an Android app, which eliminates the need for network connectivity. But it highlighted significant differences between the web and the Android APIs. They looked similar, but just porting the code across didn't work. And I identified several pitfalls, which I'll say more about later, but not in this presentation. So, as I say, the smartphone has all the sensors we need for GeoPose. It typically has a GNSS receiver to calculate location, and then it also has an accelerometer, a magnetometer, and a gyroscope, which allow us to calculate orientation. Strictly speaking, the gyroscope is optional, but it significantly improves performance. So what this app does and what the web page does is to capture a single GeoPose snapshot. And for the app rather, this is copied to the clipboard of the device. Very, very simple. But that means it can be pasted into another app, a text file, or wherever you want to put it. There are multiple settings to play with. You can choose the type of GeoPose, a basic yaw pitch roll, a basic quaternion, or an advanced GeoPose. There are two different displays. So in the picture here, you see the fixed pointer, but there's also a floating pointer display, which works in a slightly different way. And you can choose which sensors you want to use as well. So you can switch the gyro on and off to see what difference that makes. Be aware that not all smartphones have all these sensors, but the app should tell you that as well if you look in the settings, because it'll check to see what's there. What I would say as a warning is this is a sandbox. So you can turn off all the sensors if you want, just to see what happens. The idea is you can make mistakes and then correct your own mistakes, because failure is the best teacher. Get things wrong and you'll remember them. This is published by Wayteam Software, and it's free to download from the Google Play Store at the link shown. There's also more details about the development in the testbed 18 report, which is shown at the link here. That's it. Thank you for your attention.
What's happening next? So we're going to go into this sort of expanded vision of GeoPose that we're now calling reality modeling language. And to remind, it's taking the implicit region and coordinate system definition that comes with a GeoPose and making that explicit both in its extents and the identity of the entities that it can contain. So I'm going to turn things over to Mikkel here, and we're going to change the schedule a little bit. He's going to talk for 10 to 15 minutes. Then we'll have the coffee break, and we'll start the next session at 10 past 11 then.
Yeah,
So
I will
instead-
only need 5, but okay.
Yes. We're willing to get coffee sooner if necessary.
Okay,
All
but
yours.
you can hear me okay?
Yes.
Yeah. Hello, everyone. My name is Michael Salazar, and I am here to present an experimental technology we are working on in the Real Virtual Integration Working Group within the Metaverse Standards Forum. Next slide. So this is the reality modeling language, a formal language that describes, not defines, the different reality layers perceived by the users, what we call verses, independently if the entities that they contain are physical or virtual in nature. In practice, it is intended to create a planet-size interaction space where developers can not only create basic spatial extended reality or geospatial apps, but also digital ecosystems where they can easily communicate geospatial data to create user experiences that the users themselves seamlessly discover simply by walking around. Something that I personally believe can revitalize the adoption of XR technologies by allowing the users to move outside without the need of fancy AI glasses that waste resources by performing their own scene understanding of mostly unchanged environment again and again. So this is like a way to liberate the XR from the boundaries that you have to create to use them with physical security. But it is important to clarify that this is not yet another 3D format to describe scene graphs like Chronos GLTF or Pixar's OpenUSD, but rather is a language that enables the description of environments in a more open way than standards like CityGML or BIM. Because that the conceptual models of those systems allow. In a sense, RML is like a federated three-dimensional version of HTML, more focused on semantically and especially describing entities, what and where they are, rather than defining them or how they look or react to events. Next slide, please. Yeah. In fact, we care so little about how the real entities look that RML accepts different 3D representations for the same entity, whether it's triangle meshes, point cloud, Gaussian splat, CAD models. It doesn't matter because the important thing is that it is the physical description and how they relate to other entities. Because after all, in XR, we already have the most photorealistic representation of those entities. It is the extra representations are only really needed when we are using a map version of the environment or when we are integrating virtual elements on top of real ones. So you can understand that while 3D models are important, especially for virtual entities, they are not so much for the real elements. We only need a simplified physical description for that. So that we can perform, for example, occlusion mapping and put an object, a virtual object behind a real one and be able to cut the part that should not be there. What RML focus on is on defining the spaces associated to entities so that we not only properly place things in a way that makes sense for humans, so we say like the cup is on top of the table, but also can perform spatial queries such as, is the cup on top of the table? Is there a free parking near me? How can I travel, navigate to this store in the 3rd floor in this shopping mall? Those kind of questions that usually require external system, very complicated navigation mechanisms like built into the very language, into the very foundation of the system. So it's important to understand also that RML tries to create a semantic understanding of the environment. And for that, RML allows several users to create collaboratively or collaboratively describe the same things from their different perspectives. So while a table might just be furniture for most people and they don't pay any attention, an interior designer might use it to put something meaningful on top of it. Or a firefighter might mark it as something that might burn on a fire. So we can create simulations on top of it. Or simply someone wanting to eat has a good space to do it. So you can understand that the semantic and spatial definition of the environment is often more important than the representation itself. Next slide, please. Because what makes RML much more than yet another format to describe digital twins is the way it uses GeoPoses to position and orient entities and their associated spaces in the environment. Because instead of something added to add a checkbox of interoperability and leave it at that, OGC GeoPose is an intrinsic part of the language itself. So instead of defining transformation matrices like other engines with position, rotation, and scale, in RML, each entity has a pose that defines its position and orientation within a coordinate reference system defined by a space in a related entity, normally the parent. So if you move the parent entity, you move the associated entity, but not always. So if, say, the space is geographic in nature, by default, what we call the WGS coordinate reference system that represents the Earth, automatically every pose is a geopose. So it's not different. In this way, this approach really facilitates the exchange of geospatial information between different users, including robotic systems, enabling all kinds of new interactions based on collaboration. Even if in this case, it is just for the delivery robot to avoid colliding with a baby stroller that it could not have detected just with its onboard sensors because of the bus that is in the way. Next slide, and hopefully you have it. Okay, it seems like you don't have it, but I will just say that the idea is that this paradigm shift is how computer systems understand geospatial data is very powerful, but the use of GeoPose in RML is not just limited to Earth Center, Earth fixed coordinate reference systems, and in fact it can be used on other bodies like celestial bodies like the Moon or Mars to facilitate satellite communications, orienting the satellite, orienting the solar panels, or even place virtual markers on the Moon so that astronauts can safely drive in the surface of the Moon. Yeah, but coming down to Earth, this technology also has interesting applications for robotics and human factors, especially to create 3D user interfaces that adapt to the size of the arm of the user. Because in RML, geographical spaces do not have to be associated to large objects, but can be used for any rotating element, either if it's my arm or a robotic arm in a robot. So this can be used in many other applications. And if you want to see what it's already been done, you can go to this GitHub repository or can participate in the meetings in the real virtual world integration working group of the Metaverse Standards Forum, where we periodically discuss the direction of this research project. And of course, you can contact me directly via email if you have any questions I can answer right now.
Thank you, Michael. Yeah, if you have some other slides that you want to show, we can show them at the beginning of the next session. Otherwise, we actually have some time for questions for the participants in our showcase sessions.